The fastest AI chip in the world is almost useless if it spends half its time waiting. Waiting for memory, waiting for another GPU, waiting for data to arrive. And as AI models become larger and start reasoning through problems for much longer, that hidden problem gets worse. So with its new Rubin generation, NVIDIA's isn't just trying to build another faster GPU, it's trying to stop the entire AI computer from waiting. And that changes almost everything. For years, the obvious way to make AI more powerful was simple: build faster GPUs and use more of them. That worked incredibly well. The H100 was followed by the H200, then came Blackwell, and now comes Rubin, NVIDIA's next-generation GPU architecture after Blackwell. But modern AI is beginning to create a different problem. Think about a traditional chatbot. You ask it something, it processes your prompt, generates an answer, and stops. But an AI agent could do far more. It might read hundreds of documents, search a database, write some code, run that code, discover it made a mistake, try again, call another AI model and continue working before you ever see the final answer. Every one of those steps creates more computation. And more importantly, more data that has to move around. That's where Rubin starts to make sense. Inside a Rubin GPU is an enormous amount of computing power. NVIDIA rates a single Rubin GPU at up to 50 petaflops of NVFP for AI inference performance. But making the processor faster isn't enough. Imagine giving a Formula 1 car a much more powerful engine, then feeding it fuel through a drinking straw. That's basically what happens when an extremely fast processor can't get data from memory quickly enough. So Rubin gets HBM4, fourth-generation high-bandwidth memory. Unlike ordinary computer RAM sitting farther away on the motherboard, HBM is packaged extremely close to the GPU, so enormous amounts of data can move between memory and the processor. Each Rubin GPU can have up to 288 gigabytes of HBM4, moving data as much as 20 terabytes every second. And there's a reason NVIDIA needs that much bandwidth. Because the GPU isn't just crunching numbers. It is constantly pulling model data from memory, performing calculations, writing results back, then retrieving more information for the next calculation. If memory can't keep up, thousands of expensive processing units can simply sit there underused. But memory is only one bottleneck, because today's biggest AI models don't run on one GPU. They can run across hundreds or thousands. And now those GPUs need to talk to each other. That's what NVLink 6 is designed to solve. A Rubin GPU can communicate through NVLink at up to 3.6 terabytes per second. NVIDIA then connects 70 to Rubin GPUs together inside its Vera Rubin NVL72 system. And this is where Rubin stops looking like a normal computer. Those GPUs aren't supposed to behave like 72 completely separate machines. The high-speed interconnect lets the rack operate much more like one enormous accelerator, with NVIDIA describing the NVL72 as a rack-scale system where those 72 GPUs work together. And beside them are 36 Vera CPUs. The Vera CPU handles the work surrounding the GPUs, moving and preparing data, managing workloads and keeping the accelerator supply with what they need. So now look at what NVIDIA has actually built. The Rubin GPU performs the AI calculations. HBM4 feeds those calculations at enormous speed. NVLink lets dozens of GPUs exchange information, and Vera CPUs keep the entire system moving. Rubin isn't really one chip anymore. It's part of a machine designed around eliminating bottlenecks. And that matters because the economics of AI are changing. The next race isn't simply about building a model with more parameters. It's about how much useful AI work a data center can produce for the electricity it consumes. If an AI agent needs hundreds of reasoning steps to complete one task, suddenly every wasted watt and every second spent waiting becomes expensive. NVIDIA says Vera Rubin NVL72 can deliver up to 10 times the token throughput per megawatt compared with its earlier GB200 NVL72 system on certain reasoning workloads. That's NVIDIA's own workload-dependent comparison, so it won't mean every AI system suddenly becomes 10 times more efficient. But it reveals what NVIDIA is really optimizing for. Not just faster chips, but more AI output from the same limited power, space and infrastructure. And Rubin has already moved beyond a future concept. NVIDIA says the Vera Rubin platform is in full production, with manufacturers and cloud infrastructure companies preparing systems around it during 2026. Which brings us back to that incredibly fast GPU sitting around waiting. NVIDIA's answer wasn't simply to make it even faster, it rebuilt the memory around it, the connections between it, the CPU feeding it, and eventually, the entire rack surrounding it, because the next generation of AI may not be limited by how fast one chip can calculate. It may be limited by how quickly thousands of chips can work together without getting in each other's way. So that is what makes Rubin important. The future of AI computing isn't really one faster chip. It's making an entire data center behave like one. If you enjoy discovering the hidden technology behind the machines changing our world, make sure you subscribe to Knowledge Hub for more, and as always, stay curious.